Hi all, welcome to the next video on DFA. DFA, there can be five types of problems which can be asked. Like one is with starting with, or they'll ask you to construct a DFA which will accept strings that start with a particular substring. Like here, for example, we have taken construct a DFA to accept the strings that start with 10. They can ask you anything like AB or strings that accept strings that start with AB or AAB or 001 or anything like that. So that is one type of example or one type of problem which can be asked, and the second one can be substring category. Like you'll have to the starting will have some other combination, ending will have other combination. In between they'll give you a particular substring. Suppose substring AB, when they're asking you to construct a DFA to accept strings which is having AB as substring, which means that here you can have any combination of A or B, and here you can have any combination of A or B. So how will you construct DFA for that? And then the first category is starting with. So first category is starting with AB. After that you can have any combination of A and B, and ending with is you can have any combination of A and B here, and at the end it should end with AB. So this is the example. This string can vary. This substring which is given here can vary as 01 or 001 or AAB or ABA or whatever it is. So the third category is divisible by. So they'll ask you to construct a DFA which will accept strings which are divisible by a certain number, like divisible by 3 or 4 or 5. Okay, so anything like that they can ask. So you will have to construct a DFA for that. Next category is odd or even. So you'll have to find how many number of A's are there, or do you have even number of A's in a string, or do you have odd number of A's in a string, or do you have even number of A's and even number of B's in a string. Likewise, they'll ask you to construct a DFA which is satisfying that constraint. So moving on to type 1, construct a DFA to accept the strings that start with 10. So first step, whenever you are given anything of first 1, 2, 3 category is, you'll have to identify the language. That is for the first 3 categories, you should identify the language. So here it is 10, starting with 10. So the 10, after that it can be null, and the next string which we can create is 100 101. Okay, it is starting with 10, and then 1000 1001 1011 1010. So it goes on. Okay, anything which starts with 10. Okay, now you have found the language, and this is the basic string in your language. So the trick here is, when you draw the transition diagram, you should know how many number of states you will need for that diagram. So take the basic string, and the number of symbols in the string is 2. 2 plus 1 will be the number of states. Okay, so here use 3 states for the transition diagram. Okay, so let this be Q0, Q1, Q2. Okay, so this is the starting state, and let this be the final state, because it starts with 1 0. So the simplest string, it is accepted at this point. Let this be the final state. Okay, so now after this, it can accept any number, because it starts with 0 10. After that, it can have any number of any combination of zeros and ones. The only constraint is it should start with 10. So give a self loop here and make it as 0 or 1. So now it will accept any strings which is starting with 1 and 0. So the next step is, this is the transition diagram. So the next step is, you'll have to write the transition table for this. So here it will be current state, and this is the next state, that is upon receiving an input, 0 or 1, what is the next state? So write down the states which are involved here, Q0, Q1 and Q2. So Q0 is the starting state, it is represented like this, and Q2 is the final state, which is represented with an asterisk symbol. So Q0 on receiving 0, Q0 on receiving 0, there is no transition, so give it as null. Q1 on receiving Q0 on receiving 1, it is moving to Q1, and Q1 on receiving 0, it is moving to Q2, and there is no transition for Q1 on receiving 1. Okay, so it is null. Now Q2 on receiving 0, it is moving to Q2 itself, and Q2 on receiving 1, it is moving to Q2 itself. So this completes the transition table. So we'll move on to the tuple notation, how to write the tuple notation for this. So the tuple notation, it is given by, so the tuple notation of the DFA is given by D is equal to Q epsilon del Q naught and F, right? So now represent D as phi tuple notation. So Q is the set of states involved here. So Q0, Q1, Q2, and epsilon is the set of input symbols used here. So 0 and 1, 0 and 1, okay. And del is the list of transition functions which we can list down here. And Q0 is the starting symbol. So here also it is Q0 only. Q0 is the starting symbol. And F is the final state which is represented with double circle. So it is Q2 here. Okay, so this is a 5-tuple notation. Now moving on to the transition function. So transition function del is equal to current state, comma, an input. What is the next state? This is the transition function. So del, so write it for all the states. Del on current, when current state is Q0 and the input is 1, because it has no input as 0, or if you want you can write it like this, Q0 comma 0 is equal to null. So Q0 on receiving 1, it is moving to Q1. Del of Q1 comma, what is the input? It is 2, sorry 0. So next state is 2, Q2, and del of Q2 on receiving 0 is Q2 itself. Del of Q2 on receiving 0 is receiving 1 is Q2, because on both the transition it is moving to Q2 only. So when you are supposed to construct a DFA, construct the transition diagram, transition table, and write down the 5-tuple notation along with the transition function. Thank you, students.